Hello everyone, here we would like to introduce our work of polishing network for decoding of higher quality diverse image captions. In recent researches, diverse image caption generation has attracted more attention. In this task, for each given image, a model is used to generate a set of descriptions which are diverse while related to the image. Most existing methods for diverse image caption generation follow a single-pass decoding process. When generating a sentence, the sampled word will appear in the phylo-generated description and will not be further modified. This would bring two problems. First, when the mistaken word is sampled, it may affect the subsequent description. This problem is particularly prominent when we're decoding descriptions with random sampling-based methods. The second problem is that, in a single-pass process, decoders only have access to the previously generated words. The decoders are unable to predict words with an understanding of the whole contents in the sentences. While this is different for humans, when generating descriptions, rough drafts are usually generated first, then the drafts are refined to compose the phylo description. Inspired by the way of humans, we apply a similar process with the polishing network in generating diverse image captions. For the sampling methods, descriptions obtained with beam search are usually of high quality and low diversity. While with random sampling methods, we often obtain a set of descriptions with higher diversity and the calculation consumption is lower. However, the quality of the descriptions are usually lower. Incorrect words and phrases would appear in the generated descriptions. Thus, in this work, we propose a novel framework with a polishing network to refine the row descriptions. For example, in the figure below, mistaken word rice and carrots can be refined as noodles by the polishing network. Many recent works have started generating diverse image captions. Different from these methods, in our approach, the diverse image captions are generated and refined through a multi-pass process. In machine translation and standard image caption, multi-pass methods have been proved efficient. However, these works cannot be directly applied to diverse image caption generation, because there is a large gap between distributions of descriptions during training and inference. To solve the problem, we propose a novel approach to obtain row refined description pairs for training the polishing network. Methods in this work are based on the encoder-decoder structure. The sentence is usually generated one word at a time step by the decoder, and the predicted probability of the n can be decomposed as this. Different from single-pass generation process, we apply a polishing network to refine each description from the original model. The proposed polishing network is also based on the encoder-decoder structure. As shown in this figure, the polishing network encodes the row description from the original model as input. The predicted probability of the refined description can be denoted as this. During training, the original model is trained as a black box, and it is intractable to assign a refined description for each decoded row description. Refined descriptions generated from a polishing network need to be of high quality while describing similar with the row descriptions. We apply an opposite generating process that relevant row descriptions are generated from the human-labeled high-quality annotations. Then the row descriptions and the corresponding ground truth descriptions can be used as row-refined description pairs for training PN. Specifically, during training, two sampling modules are applied to the decoding process of row descriptions. We randomly sample an output word according to the predicted distribution at each time step. The hyperparameter alpha is used to control the probability of using the random sampling results. There is still a gap between distribution of the row descriptions in training and inference process. During inference, previously generated words are used as input to the original model. Therefore, we apply a sampling module to the generating process of inputs in the original model. The input word is sampled either from the predicted word or from the ground truth word. The hyperparameter beta is used to control the proportion of the generated words used as the input. We follow previous work to evaluate the quality and diversity scores of the generated descriptions in the diverse image caption generation task. We evaluate our method on the MS-COCO dataset. We use the MRNN split to train and evaluate our method following previous work. We combine PN with multiple sampling methods for decoding diverse sequences. Results are shown in the table. Applying PN to decoding process can significantly improve the quality score of random sampling methods. The figure shows a better quality diversity trade-off achieved when applying PN. We also saw the generated descriptions with quality score. The quality of descriptions from the random sampling-based methods are improved considerably. We compare our approach with existing methods for diverse image caption generation. We evaluate the Oracle scores of quality metrics and the diversity scores. A better quality diversity trade-off can be achieved with the proposed approach, comparing to existing methods. We analyze the effect of sampling modules in training PN. With larger hyperparameters alpha and beta, generated descriptions tend to be higher in quality while the diversity decreases. In order to analyze the effect of PN on the lower quality words in row descriptions, we make a statistics on bad ending words. We count the number of descriptions ending with this word. In the normal image caption generation process, we can manually filter these bad ending words with an additional post-processing. However, this post-processing requires a lot of manual work. Bad ending words are not limited to those we count. Repeated descriptions such as "there is a kite" and "a kite" are also common errors. Here we use the statistics of bad ending words as a prop to show the effect of PN. Here we show some examples of row descriptions and corresponding refined descriptions with PN. In the figure, mistaken descriptions, repeated words and phrases, grammar errors can be refined. In conclusion, we propose a novel policy network for diverse image caption generation tasks, and we propose a novel training approach to generate row-refined caption pairs for training PN. Experiments show that our approach can achieve a better quality-diversity trade-off of descriptions. That's all, thank you.